Here in Chapter 4, we are going to consider something called a discrete random variable. Let's first define a random variable. So the purpose here is to form probability models for variables that represent experimental data. So a common experiment would be to toss two fair coins, and let's say we want to count the number of heads. So if you toss two fair coins, we can find those outcomes with an outcome table. So our first coin, heads, tails, and then our second coin, heads, tails. So our sample points here are going to be heads and heads, or heads on the first, tails on the second, or tails on the first, heads on the second, tails on the first, tails on the second. So you got four outcomes, equally likely. If x is the number of heads, that actually represents a random variable. It's because we have random tosses that we get a random variable, because this is a experiment that's determined by randomness. X is going to be the number of heads. Our possible values for x would be 0, that's if you get two tails, or you could get one head in these two outcomes, or two heads there. So 0, 1, 2. So formally, a random variable is a variable with numerical values associated with random outcomes of an experiment. So there's two kinds of random variables, two flavors here. We have discrete random variables, which are random variables that take on either a finite number of values or listable infinite. So they're listable. Or there's continuous random variables. They take on any value in an interval. They're usually measurable. So let's classify some random variables here. So reaction time for hitting the brakes on a car. So that could be anywhere from, say, 0 to 10 seconds, for example. And that's measured by a watch. And that's anything in an interval. So that's continuous. Number of alcohol-related deaths per year in Kankakee County. Those would be numbers like 0, 1, 2, etc. Those are listable. So that is discrete. Rainfall in Bourbonnais last month. So that could be anywhere from 0 to, say 20 inches. That's measured with a ruler, so that's going to be continuous. The amount of gasoline sold. So the amount here is going to be gallons at a particular gas station in a week. So this could be, something like, 5,000 gallons. But it doesn't have to be a whole number. They could sell a fraction of a gallon. And in fact, a gallon is infinitely divisible. So we could say, maybe anywhere between, 5,000 and 15,000 gallons. And it can take on every number in that range. So this is continuous. You measure gallons. The amount paid for the gasoline in a week. So this would be dollars. It'd be something like, say $1,000, the receipts that they had maybe for gasoline. And then the next bigger value would be $1,000 and a penny. So digital money would be infinitely divisible, but cash money only divisible down to the penny. So for practical purposes, I think we could consider that one as discrete, because you can list a first value, a second value, etc.